Hello everyone and welcome back to SVSU's online tutoring. My name is Joel and today we will be continuing on with section 7.1 Radicals and Rational Exponents, and the topic this time is rational exponents. So to start off we have this new definition, okay? So the definition of rational exponents reads, if we let a be a real number and let n be an integer such that n is greater than or equal to 2, if the principal nth root of a exists, then a raised to the 1 divided by nth power is defined as a raised to the 1/2, or raised to the 1 divided by nth power, okay, which is equal to the nth root of a, okay? So then we say, okay, so if we're taking fractional root or fractional powers now, if we have m, which is the positive integer that has no common factor with n, then a raised to the m divided by nth power can be written as a raised to the 1 divided by nth power, which is then raised to the mth power, okay? And so then it just continues on and rewrites it using our definition. So all right here, okay? So to see that in action, if we have say 8 raised to the 2/3 power, okay? In this case, my m is equal to 2 and n is equal to 3, okay? So what I want to do is that using my definition here, what I can say is that I have 8 squared, which is raised to the 1/3 power, okay? Let me rewrite that 3 there. So raised to the 1/3 power, okay? And which is then equal to the cube root of 8 squared, okay? So now I can evaluate this. So 8 squared is 64. So I'm taking the cube root of 64, which is equal to 4, because 4 times 4 times 4 will give me 64, okay? So that's how we use our definition. We'll be seeing that a lot in future examples. So what we have done here are the summary rules of exponents, okay? If we have some number, okay, so say like 2 raised to the 3rd power times 2 raised to the 5th power, since they're the same base but with different powers, I would add the powers together and then evaluate. Likewise, if I have the same base but with different powers and I'm dividing, I subtract the powers, okay? And then if I have two numbers that are both raised to the same power, I just distribute that power and multiply the numbers as normal. And if I have some number that's raised to some exponent, which is then raised to another exponent, I multiply those two powers together, okay? And if I have two numbers being divided that are raised to the same power, I just distribute the power and evaluate those and then divide as normal. And my sixth rule is any number a raised to the 0 power will always give me 1, okay? And this is probably one of the easiest definitions to remember right here. If I have some number raised to the negative power, I just take the inverse of that, which would be 1 divided by a raised to the positive r, okay? And finally, the last rule is if I have two numbers being divided that are raised to some negative power, it's equal to the inverse of that fraction, okay? So real quickly, I will just go over that algebra. So a divided by b raised to the negative power r. Well, what I have to do is that I have to apply rule 5, right? And distribute the power to both of these numbers. And now I can use rule 7, where if I have some number raised to the negative power, I take the inverse of that to make it positive. So I have a fraction divided by a fraction, which will give me a raised to the r power times b raised to the r power, which is equal to b raised to the r power divided by a raised to the r power. And then I can just factor out my power. So I have a divided by b raised to the r power. Okay. So that's just a quick gloss over for the rules. Whoops. Let me change the color here. There we go. Okay. So now what I want to do is just do a couple more examples, and then I will stop the video there, because this will end up being 2 parts. Okay. So if I have 5, let me go back to my pen here as well. If I have 5 squared raised to the 3/2 power, this is an application of rule number 4, right? So I have 5 squared times 3/2. So these 2's cancel, right? So I have 5/3, which is 5 cubed. So 5 times 5 times 5 will give me 125. If I have some number 16, which is raised to the 3/2 power, because I have a negative power, what I have to do is that I have to use, I think it was rule 7, and throw this into, take the inverse to make that power positive. And now I can use my definition for rational exponents and rewrite this as the square root of 16 cubed. Okay, and 16 cubed is 4096. Okay, which is a perfect square of 64. Okay, so my answer is 1 divided by 64. If I have 2 numbers that are being divided, which are raised to the 3/2 power, what I have to do is that I have to distribute my power to each of these numbers, right? So I have 4 raised to the 3/2 power divided by 9 raised to the 3/2 power. And I have to use my definition for rational exponents to rewrite this. So I have the square root of 4 cubed divided by the square root of 9 cubed. And 4 cubed is 64, so I'm taking the square root of 64, divided by 9 cubed, which is 729. So I'm taking the square root of 729. The square root of 64 is 8, and the square root of 729 is 27. Okay, and scrolling down here. If I have negative 64 raised to the 1/2 power, that's equal to negative the square root of negative, oh, I'm sorry, I still have my negative sign out here, and I'm taking the square root of 64, okay? The square root of 64 is 8, so my answer would then be negative 8. But if I have negative 64 raised to the 1/2 power, I would write that as the square root of negative 64, which would give me a non-real number, okay? So the difference between these two is that in the first one, only 64, the power is only being applied to 64 here, okay? So you can imagine that the 64 is in parentheses, and then it's being multiplied by this negative sign. Whereas in the second case, the negative sign is included. So when I'm taking the square root, it's being applied to both this negative sign and the 64. But as of right now, we don't have any tool to evaluate this radical, so we just say that it's equal to some non-real number. And the last, okay, so that's actually the last example, and we will continue this with part 2, and in that one we will be focusing on variables instead. Okay, see you next time.